Good day, students. This video is about polymorphism. To understand the concept, let's look at the inheritance diagram on the left-hand side of your screen. We've got a superclass mammal divided into two subclasses, human and animal. Animal is again divided into fish and then other is divided into bird, dog, and frog. If we want to, for instance, write a game with a human, fish, bird, dog, and frog as part of our game objects, must be inside our game. We want to let these objects perform specific tasks. Let's say move forward is one of the tasks that we want all our specific objects to be able to perform. All of those classes, the human class, the fish, bird, dog, and frog class, because it's a compulsory movement, so it's a compulsory method that I want in my subclasses. But the content on how to move forward will be different in each of these classes. A human will move in a different way, so the description for move forward will differ from that of a fish or a bird, and so on. So when you execute the program, how this method will be executed will depend on the specific object. So that is polymorphism. Poly means many, morphism means forms. So the movement will be done in many different ways depending on the object. Then another thing is when we code this, we can't create an object because a mammal, if I need to code the move forward for a mammal, I can't really do that because I don't know the specific type of mammal I'm coding it for. So a superclass, we want the programmers not to create objects of superclasses because we don't know enough about superclasses to write specific methods for those classes. Same with animal. How do I write a move forward method for an animal if I don't know the specific type of animal? So we must also in our code try and avoid programmers to write objects or create objects of superclasses. Now with that in mind, let's look at one of the assignments you did last week. It's the one on the clients to apply polymorphism. So the first thing we do is the superclass client. We make this superclass an abstract class. So we put the keyword abstract, public abstract client, because we would like the programmers not to be able to create a client object. If I make a class abstract, you can't create an object of that class, which is exactly what we want because we say a client doesn't have enough information to be able to. Let's go back to our layout. I'm just going to compile here. If we look at this layout, we've got a company client, savings client, check client, and a student client. All of these clients must get a certain amount of interest from the bank. It's compulsory. The bank must pay interest, this specific bank. So we want that method to be part of all our subclasses. And we don't want a client object to be created because the type of client will determine the interest. If it's only a client, it's too vague. I can't create an interest amount for a client because I must know what type of client it is. That's why we make our client superclass an abstract class. The next thing we do is we force our subclasses to contain the specific method that we need, the calc interest. If we open this company client, There's the compulsory method. We already coded it last week. Calculate interest. This method must be in all my subclasses. So what I do is I copy the heading of this method. I go to my superclass, go down the method, I paste, oh man, no, let me just take it there and paste it there. And I put a semicolon at the back and I make it an abstract method. So what is an abstract method? It's a method with no code, only the heading. It has no implementation. That's what they call it in the textbook. So most textbooks, that's what an abstract method, the description of an abstract method. It's a method with no implementation. But if I list it here in my superclass, it must be part of all the subclasses. So let's close this. Let's compile everything. We can run it. It will work. There's my output. All right. So let's go now into one of the classes. Let's say the savings. We go here and we put this method in comments. So now this class doesn't have a method, calculate interest. So let's compile this class now. Okay, tells us savings client is not abstract and does not override the abstract method calc interest in client. So it's saying client wants a calc interest method and it's not here. So there's an error. So let's go back in the savings class. Let's take out the comment. Let's uncomment. We can compile everything again and there it compiles. So that's the first thing. I make my superclass, I list the compulsory method as an abstract method with no implementation. I just put the heading there. Now all subclasses must contain that specific method. The next thing is I make use of the interface class. All right, so now to create an interface class, you go new. There's an interface option, interface class, and you just give it a name. In this case, we said clientable. The name clientable, the interface, the convention is that the name of your interface class must end with able. In this case, we take this, there's a combination of the superclass and able, clientable. Name it like that. So we all know when we see a class ending with able, it's an interface class. So that's how you create it. I'm just going to, for now, just make a temporary one just for you to see what it looks like. The content, that's what it looks like. You just delete all of that and you put your code in here. But I already did it beforehand. So let's look at the content. In my clientable class, I put the heading of my calc interest method, only the heading, and then I would like all my subclasses to have a toString method. So the interface class is a class that will contain only the headings, or we call it definitions of your methods that's compulsory in all your subclasses. All right, so now I compile that one, my interface class, and it sits there. But now I need a link between my superclass and my clientable class. So I go into the superclass, go up at the top, implements, and I put the name of my interface class. Compile. If I go back, there you see the link. I can run everything now. it should still run with my clientable interface class. There you have it. So this structure here is now enforcing polymorphism. If we look at our, I think let's just discuss the next part, the test class, in our next video.